Good afternoon, children. Welcome back to chemistry class. From last class onwards, we have started our syllabus. I hope everyone doing well. Children, everyone should write homework without fail. It is very easy to remember all your portions clearly. Watch the class carefully. Take notes, study, and write the homework and send me through my WhatsApp. Okay? Yesterday, we have learned introduction about atom model, Rutherford atom model, Bohr atom model, and then limitations. Okay. Today, we are going to study about wave-particle duality of matter. Wave-particle duality of matter. And then, quantization of angular momentum and de Broglie concept. Quantization of angular momentum and de Broglie concept in your textbook page number 40 and 41. If you are having textbook, you take and refer. Otherwise, you take notes. Okay, all of you should take notes. This is very easy to remember. First upon, wave-particle duality of matter. Wave-particle duality of matter is very important question for 3 mark. Very important. Listen carefully. Very important. Wave-particle duality of matter. What do you mean by duality? Duality means, you know, dual means two. Whatever two character, duality means two character, two properties. Whatever two properties duality means, there is wave nature and particle nature. So duality means wave and particle nature. Duality means wave and particle nature of matter. Okay, what about wave nature and particle nature? How will you understand about that? Wave means this, like this wave. Okay, particle means small particles or big microscopic or macroscopic particles. These are the particles. Okay, so wave character means we can measure from the wave nature, we can measure the wavelength and then frequency we can measure. And about particle means we can measure the particle, the mass of the particle and then velocity of the particle. We can measure the mass and velocity. This about wave and particle nature. Okay, let us come our topic. According to Albert Einstein, one of the scientists, he proposed light has dual character. Light has dual character. What about dual character? Wave character and particle character. Wave character and particle character. You know about wave character means light have the wave character. Particle, how the light has particle character means photons. When you are striking the light in a metal or any metallic objects, we are striking the light particles through any objects. We can measure the particle nature of light. We can measure the particle nature of light. Okay, so this concept Albert Einstein proposed. Albert Einstein proposed that the light has wave character and particle character. But another one scientist, de Broglie suggests all the forms of matter shows dual nature. All the forms of matter shows dual nature. What do you mean by dual nature? Dual nature means both wave nature and particle nature. All the matter shows dual and nature, wave nature and then particle nature. How he confirmed that to dual nature? For that he take two hypotheses. For that he take two hypotheses. Whatever hypothesis? First one, Planck's hypothesis. Planck's hypothesis. Secondly, Einstein mass energy relation. Einstein mass energy relation. What about Planck's hypothesis? What about Planck's hypothesis? Planck's hypothesis means E is equal to h nu. E is equal to h nu. What of this equation number 1? What about Einstein mass energy relation? E is equal to mc square. E is equal to mc square. We take this equation number 2. When comparing equation 1 and equation 2, comparing equation 1 and equation 2, the E is equal to h nu according to Planck's hypothesis is equal to mc square according to Einstein mass energy relation. We're taking the E value h nu for this E. H nu is equal to mc square. This is equation number 3. Here, nu is equal to c by lambda. This is one of the concept. Nu, frequency is equal to velocity divided by wavelength. Nu is equal to c by lambda. We can substitute this new equation to the equation number 3. H into c by lambda is equal to mc square. On rearranging the above equation, we can take lambda, we can calculate the wavelength, we can measure the wave nature of the particle. So lambda we take out, lambda is equal to hc by mc square. hc by mc square. And we can cut the c and c square, then we get lambda is equal to h by mc. H by mc. This equation represents the wavelength of the photon. Wavelength of the photon or wavelength of the light we can measure from this above equation. For a particle of matter, how will you measure? Particle of matter, we can measure the lambda is equal to h by mv. Use this formula, we can calculate, we can measure the particle of lambda. We can measure, but the particle, it is very less, very small particle, only we can measure the wavelength. Okay, the particle of the matter, it should very low when compared to size of the atom, then only we can measure the wavelength of the particle. Okay, understand? For example, the microscopic particles such as electron, the mass of the electron 9.11 into 10 power minus 31 kilogram. Mass of the electron value, this is very, very low mass when compared to the size of the atom. It is very, very low. So we can measure the wavelength of this electron, we can measure. Okay, so what's concluded with here? When mass of the matter, low, wavelength will be high. When mass of the matter high, wavelength will be low. Okay, let us understand this by calculating de Broglie wavelength From two calculations, here having two calculations, we can understand about the de Broglie wavelength. We can understand first upon question number 1. A 6.626 kilogram iron ball moving with 10 meter per second. Question number 2. An electron moving at 72.73 meter per second. Let us calculate the wavelength of the two questions. First, question number 1. What's the formula to measure the wavelength of the particle? Lambda is equal to h by mv. What about the given? Given h, you know, h represents the Planck constant. What's the value for the h? 6.626 into 10 power minus 34 kilogram meter square per second. And the mass, what is the mass of the particle, mass of the iron ball? Mass means m is equal to 6.626 kilogram. What about v? V means velocity. Yes, 6.626 kilogram iron ball moving with 10 meter per second. 10 meter per second. So, what about the v means velocity, speed, velocity 10 meter per second. Okay. Let us substitute this value to this formula. Lambda is equal to, what's the h value? 6.626 into 10 power minus 34 by, what's the m value? 6.626 kilogram. You should write the unit kilogram. The h value kilogram meter square per second. Here also m 6.626 kilogram into v 10 meter per second. Okay. With similar terms we can cut. Okay, kilogram and the kilogram we can cut, and meter square and then meter we can cut, and then after that the second inverse and second inverse we can cut. Okay, so we get 6.626 by 6.626 we get 1. So lambda is equal to 1 into this 10 goes the numerator. So we get 1 into 10 power. When it will becomes from the numerator 10, it becomes 10 power minus 1 into 10 power minus 34. Okay, this 10 power minus 1 and 10 power minus 34 we get 1 into 10 power minus 35. 1 into 10 power minus 35 meter. You can understand, this is the wavelength of the first question. And what about the second question? An electron moving at 72.73 meter per second. Okay, how will you write? What is the formula for calculate the wavelength? Lambda is equal to h by mv. What about the given? H means Planck constant, you know. What is the value for Planck constant? 6.626 into 10 power minus 34 kilogram meter square per second m. Here the mass of electron, okay, mass of electron, an electron moving at, what is the mass of electron? You know, 9.11 into 10 power minus 31 kilogram. Okay, and V, here what is this question here? An electron moving at 72.73 meter per second. Velocity means speed. V means 72.73 meter per second. Okay, we can substitute this value to this equation. Lambda is equal to h. What's the value of h? H 6.626 into 10 power minus 34 kilogram meter square second per second. And then m means 9.11 into 10 power minus 31 kilogram, and V 72.73 meter per second. You can cut the units first, kilogram and then kilogram, meter square and meter, second inverse and second inverse we can cut. Okay, here 6.626 into 10 power minus 34 by 9.11 into 72.73, we can multiply. We are multiplying by these two, we can get 662.57. Okay, and by dividing these two, 6.26 divided by 62.57, we get 0.01, and this into 10 power minus 34, and this 10 power minus 31 goes to the numerator to become plus minus, it goes numerator, it will be plus 10 power 31, so 0.01 into minus 34 plus 34, we get 10 power minus 3. Okay, is equal to 0.01 into 10 power minus 3. Okay, and these two in the point will be come after the 2 digit. 1 into 10 power minus 5, the 2, 10 power minus 2, we can add the minus 3, 1 into 10 power minus 5. Okay, when comparing these two answer, this is the answer for wavelength of the electron, second answer. And what about the first answer? First answer, it is the wavelength of iron ball. When comparing these two answer, the wavelength of iron ball, it is very small, 1 into 10 power minus 35 meter, very less, very less. But wavelength of electron, 1 into 10 power 5 meter. When comparing these two, wavelength of electron, it is, we can measure, it is big, 10 power minus 5 it is, we can measure. For the electron, the de Broglie wavelength is significant and measurable. For the electron, the de Broglie wavelength is significant and measurable, while the iron ball, it is small, very small, too small to measure, hence it becomes insignificant. Okay, so concluded, The de Broglie concluded that all the matter shows the dual character, but the wave character of particle, if we measure the wave character of particle, the particle size should be very low. The mass of the particle should very low. Then only we can measure the wavelength. If the mass of the particle is high, we cannot measure. This is insignificant to measure. Okay, understand? Then, what about the second question? Quantization of angular momentum and de Broglie concept. Quantization of angular momentum and de Broglie concept. According to de Broglie concept, the electron that revolves around the nucleus exhibit both particle and wave character. According to de Broglie, we studied the electron that revolve, this is the nucleus, electron that revolve around the nucleus in a circular path, and this electron has dual character, wave character and particle character. Wave character and particle, how the electrons are revolving around the nucleus in phase. In order to electron wave to exist in phase, okay, when the electron revolving around the nucleus exists in phase, the circumference of the orbit, that is integral multiple of the wavelength of the electron wave. The circumference of the orbit, it is integral multiple. Integral multiple means n. Integral multiple of the wavelength of the electron wave. When, according to de Broglie concept, the electrons revolving around the nucleus exhibit both wave character and particle character. In order for electron wave to exist in phase, the circumference of the orbit, it is integral multiple of the wavelength. Otherwise, the electron wave is not, it is out of phase. Out of phase means it is not revolving around continuously. It is not in continuously. Electron revolve around the nucleus not in continuously. It is out of phase. It is circumference, it is out of phase. Okay. The electrons revolve around the nucleus, exhibit both wave character and particle character. At the same time, the circumference of the orbit is equal to integral multiple of wavelength of the electron wave. Okay. Circumference. What do you mean by circumference? What is the circumference of the circle? In your lower class, all of you learned about that. Circumference of the circle, that is 2 pi r. You know, 2 pi r, that is equal to n lambda, integral multiple of wavelength. Okay, so 2 pi r is equal to n lambda. When the lambda value, you know, what is the lambda value? Now we studied lambda is equal to h by mv. So 2 pi r is equal to n into h by mv. And then on rearranging this above equation, the above equation, MVR is equal to NH by 2 pi. NH by 2 pi. You know, the MVR means angular momentum. Already we studied MVR means angular momentum. Angular momentum MVR so angular momentum is equal to NH by 2 pi. The above equation was already predicted by Bohr. Yesterday we studied about that angular momentum. It is MVR. MVR is equal to NH by 2 pi. This equation was already predicted by Bohr. Hence, de Broglie and Bohr's concept are in agreement with each other. De Broglie and Bohr's concepts are in agreement with each other. Okay, students, I hope all of you understood clearly. Okay, students, today assignment explain wave particle duality of matter. Wave particle duality of matter. Okay, once again I repeat, wave particle of matter. It is explained by de Broglie. For that, de Broglie take the Planck quantum hypothesis and Einstein mass energy relationship. So according to Planck quantum concept, E is equal to h nu, and Einstein mass energy relationship is equal to mc square. When comparing the two equations, we get lambda is equal to h by mv. Lambda means wavelength. From this equation, using this equation, we can measure the wavelength of the particle. Wavelength of the particle, and the two calculations are there. What about two calculations? Here, de Broglie comparing how the wavelength, how we can measure the wavelength of the particle. Finally, he suggests that the wavelength is significant and measurable while the particle is too small. Wavelength is significant and measurable while the particle, it is too small to measure. Okay, hence it becomes insignificant. Okay, these are the matter we studied. Study well and write and send me through my WhatsApp number. Clear? Thank you all of you.